Let's start from the first one, firm demand of labor. In this question, we have this table, give us the information of relationship between the number of employees and quantity of fish produced. So for instance, number of employees goes from 1 to 8, and then we have the corresponding quantity of fish. And we know that the market price for the fish is 50 Swedish crown per kilogram, and the wage rate is 750 per hour. And then we need to show following questions. We need to solve following questions. So first, we need to calculate marginal product of labor based on the information given in exercise 1, and we need to show this curve, marginal product of labor, in a diagram. And then we need to compute the marginal revenue product of labor of employee, and then also we need to show this show the curve of marginal revenue product of labor. And then we need to find out how many people will the factory employ. And yeah, then we need to analyze if there is like change in price from 50 per kilogram to 33 per kilogram. Then how does the marginal revenue product change? Yeah, and also we want to know, like, given this new price, how many workers will the factory employ? And last, we want to analyze how many workers will the factory employ if the salary drop to 600 per hour. Okay, let's solve this one. So question 1, let me first write down this table, copy the table. So we have, okay, so question 1 is about firm demand of labor. So first, let me use this L, capital L, to denote for the number of employee. So employee goes from 1 to 8. And then the Q, the corresponding production level is, let me copy these numbers, 20, 50, 90, 120, 145, 165, 180, 190. Right. Also, we know that the price is 50 per kilogram, wage is 750 per hour. Okay. So first, we want to solve marginal product of labor. So what is marginal product of labor? That is the production produced, output produced due to 1 unit increase in employee, right, in labor. So formally, I can write it as change in quantity to change of labor, right? So how the employee increase affect the total output. Then we can using this formula, we can solve the marginal product labor. For instance, for the first labor, first unit, we know that when labor increased from 0 to 1, this quantity increased by 20. So then change in Q to change in labor is 20, because Q goes from 0 to 20. What about the next row, second unit of labor? When labor goes from 1 to 2, so labor increased by 1 unit. What about Q? Changing in Q, 30. And changing in Q to change in labor, that's 30 divided by 1 is 30. What about the next one, the third labor? So if the labor increased from 2 to 3, changing in Q, the quantity of production increased by 40. And then we can do the same for the rest of labor. So for instance, next one is 30, and then 25, 20, 15, and 10. Okay, and then we can simply plot this graph like we did in previous exercise sessions. So we have, for instance, we have like marginal product of labor, and labor is a function of labor, right? So basically, I mean, labor goes from 1 to 8. So 1, 2, 3. Then what you need to do is just to plot this labor and the marginal product of labor in this figure, right? So for example, when labor equal to 1, marginal product of labor is 20. If you plot this, you will get a graph look like this. Let me just show you the graph. So okay. So if you plot this labor and marginal product labor, you will get a graph. So let me write this as marginal product labor. Second, what is marginal revenue product labor? We know that marginal revenue product labor equal to price times marginal product labor, right? Because price is the, I mean, revenue per unit, and times the marginal product of labor, then you will get marginal revenue product labor. So in this table, I can write this as marginal revenue product of labor for price P equal to 50, right? then the marginal revenue product of labor is computed as, for example, 50 times 20. That's the marginal revenue product labor for the first labor, right? That's 1,000. The next one is 50 times 30, 1,500. The next one is 50 times 40, 2,000, right? And we do the same for the rest of the labor. So next one is like 50 times 30 again. So it's 1,500. Next one is 1,250. Next is 1,000, 750, and 500. Okay, then we have marginal product labor when price equal to 50. Graphically, it's just a shape. It's just we just need to shift marginal product labor upwards, right? Because marginal revenue product labor is the product of marginal product of labor times a constant factor times 50. So all the marginal product of labor is scaled up 50 times. So you just need to shift this curve, for instance, upwards to somewhere here. So let's say here is marginal product labor, marginal revenue product labor. It's also our demand. Right, so that's question B. Question C, how many workers will this factory hire? We know that the firm will hire the worker at marginal revenue product labor equal to the wage rate, because marginal revenue product labor is the revenue you can get from hiring one additional worker, and the wage rate is the like marginal cost for hiring that additional number of labor, right? So these two, if these two are equal, then it's optimal for the firm, for the factory. So we know that wage rate is 750, right? And for the marginal revenue product labor, if it's 70, then it means the firm will hire how many units of worker? Will hire how many workers? It's 7, right? So when L equal to 7, and then we have marginal revenue product labor equal to wage. So graphically, let's say we have here is our wage equal to 750. And this intersection point, when marginal revenue product of labor equal to wage, we have labor equal to 7. Okay, for question C, we have marginal revenue product of labor equal to wage rate, which is 750. And in this case, we have labor equal to 7. Okay, next one. If the price now goes down from 50 to 33, Then what is the new marginal revenue product labor? So marginal revenue product of labor equal to price times marginal product labor. We know that this term is unchanged, right? So it's unchanged. Marginal product labor is unchanged, but the price goes down from 50 to 33, right? Then this will decreases marginal revenue product labor, right? So in this table, for example, we have marginal revenue product labor given the new price 33. Then we can compute this. Let me give some space here. We can compute this new marginal revenue product labor given the price equal to 33. What we need to do is to just simply use 33 times 20 instead of 50 times 20, okay? And 33 times 30, and so on. Because now we have a lower price. And then we get 660, 990, and here is 1,320. I mean, you can just use your calculator to compute if you need. So 990 and 825, 660, 495, and 330. And if you plot this one in the graph, you can see that we still need to shift the marginal product of labor upwards, but we don't need to shift as high as when P equal to 50, because now all the marginal product labor is scaled up by 33 times instead of 50 times. So here, for instance, we have it should be like parallel shifting. Okay, so this is the new marginal product of labor when price equal to 33. Then how many workers will the firm hire in this case? We know that when labor equal to 5, then we have 825. This one is greater than the wage rate, which is 750. And when labor equal to 6, then the marginal revenue product labor is smaller than the wage is, right? So basically, when you hire five people, the fifth people, that worker's marginal revenue product labor is greater than the wage or the cost. And but when you hire one additional, the sixth worker, then that additional, the sixth worker's marginal revenue product labor is a loss compared to the wage you need to pay to that worker. So basically, in this case, the firm will only hire 5 people because the sixth one generates a loss. 660 is smaller than, like the contribution or the revenue is smaller than the wage, 750. Okay, so if we look this from the graph, we can see here, when labor equal to 5, this marginal revenue product labor, and when P equal to 33, this one is greater than 750, right? And when it's 6, it's smaller than this 750. So basically, the firm should hire like how many workers? 5, right? When labor is 5, marginal revenue product labor is greater than wage. When L equal to 6, this marginal revenue product labor is smaller than wage. So the factory hires 5 people, right? So what if now the wage decreases from 750 to 600 to 600? What is the decision now? How many workers should the firm hire? Then we should compare this 6 and we should compare this one, and the new wage, right? Because new wage is 600. Basically, now the firm should hire 6 workers, right? Because the 7th worker's marginal revenue product is smaller than wage. So when labor equal to 6, marginal revenue product of labor is 660. It's greater than this new wage, 600. But when labor is 7, marginal revenue product labor is 495. It's smaller than wage. So now the firm should hire 6 people instead. Okay. So that's question 1. Any questions? So here is, it's a simple setup here. So basically, if you have, because here, if you hire like 1 additional worker, what is the cost for that additional worker? It's wage, right? Okay, so let's move to next one. Monopsony. So monopsony, what is monopsony? I mean, it's comparable to monopoly case, right? So monopoly is first of all, both cases, monopoly and monopsony, they has the market power, right? But the difference is monopoly, they have it's the single seller in the market, and that firm can set the price. Monopsony is the single buyer in the market, For instance, in a local employment market, there is like one big firm, and this firm is the only firm in this region, and then this firm is the monopsony. So so let's use this question as an example. So first, we know these companies' demand, and we know the we know supply. And the first one, we need to determine the wage and employment if in a perfect competitive market. And then we need to determine the wage and the employment given the firm has monopsony power. And last, we should analyze the welfare effect between two markets. So let me first write down the demand and the supply. We have demand equal to 450 minus 50 times wage. Supply equal to 100 times wage, right? So first, in perfect competitive market, the equilibrium or equilibrium wage and labor demand and labor, right? So similar to other goods market, to find this equilibrium in perfect competitive market, we just need to equalize labor supply and labor demand. For instance, if I equalize labor demand and labor supply and solve this equation, right? So this is the wage rate. And if we just insert this wage into either labor supply or labor demand, we can get labor, the employment level. So let's say if we insert this wage into labor supply, then we know the employment level is 300. Okay, second, if the firm has monopsony power, then what is the wage and the employment? In this case, the employment is determined by when marginal cost equal to marginal revenue product of labor, right? So first, what is marginal cost? Marginal cost is the cost of hiring one additional worker, right? The change of cost due to hiring one additional worker, right? Do we know the total cost? Because we want to know the change of total cost. And first we need to know the total cost to solve for the marginal cost. Total cost for the firm is wage times labor, right? And what is wage? So if you look at here, so from the supply, the labor supply, we have labor equal to 100 times wage, and the inverse supply is wage equal to inverse of 100 times L, or 0.01 times L, right? (0.1 times L. I just insert this wage into here. Okay, times L, then I get 0.1 L squared. Right. So this is just the inverse labor supply, right? And then we can compute the marginal cost by taking the derivative of total cost with respect to L. So take the derivative of this guy with respect to L, we will get 2 times 0.01 L power to 2 minus 1, right? So this is 0.02 times L. Okay. So this is our marginal cost. As I mentioned, we need to find out. We also need the marginal revenue product labor, right? So what is marginal revenue product labor? That's the demand, right? Sorry, the inverse demand. So how to compute the inverse demand? I just put this term with wage on the one side of the equation, for example. So here it's labor demand. 50 times wage equal to 450 minus L. And then I divide both sides by 50. 9 minus, right? Or this just 9 minus 0.02 L. So basically, marginal revenue product labor equal to 9 minus 0.2 L. So we have marginal revenue product of labor. And to find the wage and the employment level, we can equalize these two. Equalize marginal cost and the marginal revenue product labor. Okay, so if I move like all the term with L on one side of the equation, then I have 0.04 L equal to 9, and the employment should equal to 225. And what is the wage? If you just insert this L into the inverse supply, L divided by inverse supply is here. Let me show you here. I mean, we just compute this inverse supply, right? Here. So 0.01 times L. Okay. And then let me show you in this graph. So first, what is marginal revenue product labor or demand? Here, right? So this is our intercept, and the slope. Okay, so here is 9, it's the slope, right? So marginal revenue product labor, which is equal to 9 minus 0.02 times L. Okay, what is the supply? Inverse supply. Let me use this one. What is the inverse supply? Here, right? So 0.01 times L. And there is no intercept. Slope is 0.01. And then we have marginal cost, which is here, equal to 0.02 times L, right? So how do we determine the employment level and the wage? In monopsony case, it's one marginal cost equal to marginal revenue product of labor. And then we have this, employment level, which is here 225, and the corresponding wage at this point. We need to find the wage along the supply, right? So that's 2.25, right? So compared to previous case, in a perfect competitive market, in perfect competitive market, we have this employment level at 300. So here is our here is 300, and we have like wage is at 3. So here is 3. Okay, that's the 2 different cases. So what can we say about this welfare? We can see in this graph, previously we have 2 big triangles. Now this part, let me use this color. This part has moved from consumer surplus to producer surplus. Move from producer surplus to consumer surplus, right? So previously this part belongs to producer surplus. Now is part of the consumer surplus. And we should also notice that now we have this deadweight loss due to this monopsony power. Because the firm now only hire 225 workers and at a lower wage. And that red triangle just disappeared, that part of welfare just disappeared. And then the green rectangle part of welfare now now goes to the like consumer surplus. I mean, the consumer surplus is this monopsony, this firm, the firm demand worker in this case, right? It's the like opposite direction of the monopoly case. Any questions? Let's move to question 3, game theory part. In this question, we have 2 companies. I mean, we have information of a payoff table for 2 companies. So here is car company 1. So 2 companies produce car. And this is company 2. Each company, they have 2 options or 2 strategies. They can either produce low quality car or high quality car, right? And they have the same strategies. And this is the payoff for 2 companies. The first number is the payoff for company 2, and second number is the payoff for company 1. So this is, I mean, quite standard way of denoting the payoff of showing, I mean, standard way of for this payoff matrix or payoff table in game theory. So yeah, then we need to analyze this game. So first we need to describe this payoff matrix or outcome matrix in words, and then we need to analyze if there is any dominant or dominated strategies, or if there is any equilibrium. And then we also need to analyze this famous prisoner's dilemma game and explain how it works. And if this game is played or it's repeated infinitely times, that's the result change, this prisoner's dilemma. Okay, let's solve this one. First, let me copy the table, the payoff matrix. I use C1 to denote for the company 1. Low quality, here high quality are 2 strategies. It's the same for company 2. Low quality, high quality. Then we have pairs of payoffs. So 3, 1, 1, 2, 4, 5, 2, 4. Okay. So as I mentioned, the first number is the payoff for company 1. Sorry, for company 2. Sorry. So the first number is payoff for company 2. Second number is payoff for company 1. Right. Okay. So first, let's describe this game in words. Okay. So first, we can analyze the best response for company 1. So for company 1, if company 2 choose to produce low quality car, okay, if company two choose to produce low quality car, then what is the best response for company one? So basically, company one needs to compare between two payoffs. Company one needs to compare one or two, right? Because company two choose to produce low quality car. Can you tell me which one is the best response for company one? It's to produce high quality car, right? Because two is greater than one. Okay, two is greater than one. What if company two choose to produce high quality car? Let me first write first. So if company two choose to play low quality car, then company one will choose to produce high quality car because two is greater than one, right? What if company two choose to produce high quality car? It's 4 better than 5 or 5 better than 4? Which one is larger? The larger, the better, right? 5 is better than 4. So company one now choose to, the best response for company one is to produce low quality car, right? Because 5 is greater than 4. So I mark the best response payoff with the right underline, okay? And I will do the same for company two. Company two's best response, okay? So let me continue. For company two's best strategy or response, if company one chooses to produce low quality car, what is the best response for company two? Remember, the first number is the payoff for company two. Company two should produce high, right? Because 4 is greater than 3. If company one chooses to produce high quality car, what is the best response for company two? Also high quality car, right? Because 2 is greater than 1, right? 2 is greater than 1. So it's preferred to produce high quality car for company 2. Okay, it seems like regardless of how company 1 chooses to produce, it's always the best response for company 2 to produce high quality car, right? It's always better to produce high quality car for company 2, right? So in this case, we say that high quality car, to produce high quality car is a dominant strategy for company 2, because no matter how company 1 produce, it's always preferred to produce high quality car. And then that strategy is a dominant strategy. So say 2 has a dominant strategy, which is produce high quality car. What about C1? C1 has no dominant strategy because C1's strategy or best response depends on C2's strategy. In that case, there is no dominant strategy because it depends on C2's strategy, company 2's strategy. Do we have a Nash equilibrium? Yes. It's obvious. It's this one, right? Why? Why is obvious? Because this 4 and 5 I marked with 2 underlines. What does this mean? As I mentioned, I will mark the best response strategies pay off with the red underline. And if this pair has 2 red underlines, it means they are the best response to each other. So if they are the best response to each other, then no one will deviate from this pair, and this pair is a stable pair. So it's a Nash equilibrium. So Nash equilibrium is when company 2 play high strategy, company 1 play low strategy. So high-low is a Nash equilibrium. As you may notice that I use high-low instead of 4-5, right? Why I use high-low instead of 4-5? Because high-low these are the strategies. Nash equilibrium. I mean, here is strategies, and here is just payoff. So when we talk about dominant strategy or Nash equilibrium, we are talking about strategy. That's why I need to write high-low and not 4 and 5, because that's just payoff. Okay. Next, we need to give example for prisoner's dilemma. So let me give you this example. I mean, use the same story. We have 2 companies, company 1, company 2, low and high, low and high. So for example, 4 minus 1, 5 minus 1, 2, 2. Okay. So first we can underline all the best response as we did in the first game table, in the first payoff table. Okay. So first, it doesn't matter which company you start first. For example, let's start from company 2 first. If company 1 play low, choose to produce low quality car, then what is the best response for company 2? It's 5, right? It is to produce high quality car, because 5 is greater than 4. Okay. And what if company 1 chooses to produce high quality car? What is the best response for company 2? It's also it's also preferred to produce high quality car for company 2, right? Because 2 is greater than -1. Okay, in this case, we can see that high quality car is a dominant strategy for company 2, right? Because no matter how company 1 choose to produce, it's always the best response for company 2 to produce high quality car, right? Now let's look at company 1. If company 2 choose to produce low quality cars, what is the best response for company 1? Company 1 should produce high quality car because 5 is greater than 4, right? And what if company 2 choose to produce low quality car? What is the best response for company 1? Also high quality car, right? Because 2 is greater than -1. Okay, then in this case, high quality is also a best response or dominant strategy for company 1, right? Do we have a Nash equilibrium? Yes, as I mentioned, if a pair marked with 2 underlines, then this pair must be a Nash equilibrium because it's a stable pair it's the best response for each other, right? So high is a Nash equilibrium. So what is the dilemma here? what is the dilemma? We can see that here, for the low strategy, we have payoff with 4 and 4, right? So payoff doubles for both companies, right? So why these two companies? Why don't two companies just play low, just produce low quality and low quality cars? Instead, both of them produce high and high quality cars. What's the reason? Because low is unstable. It's not Nash equilibrium. Okay. For example, if two companies, if they agree to form a cartel or some kind of collaboration, they have some kind of agreement that they want to collaborate. Okay. And in this case, if company one, if one firm, if company one, for example, deviates from like this, if company one cheats, like by producing high quality car, then company one will get a better payoff 5 instead of 4, right? And in this case, company two will lose quite much, from 4 to -1. Okay, and why this is not stable? Because for company one, 5 is greater than 4, so there is incentive to deviate from this because it is more profitable for the company. And for company two, if company two might think I'm suffer this risk of getting -1 payoff, and this risk is quite high for me because there is incentive for company one to deviate. In this case, this pair can never be a stable pair, even if this pair give higher payoff than 2-2, but it's not stable because there is incentive to deviate and there is a risk to get lower payoff for both companies. So although for 4 is greater than 2-2, there are incentives to deviate from that outcome. And last, what if this game is repeated infinite times? Does the result change? Yes. So I will not write down this because you will get this. You have the solution on my Moodle, so I will not write down this. I just explain. Okay, because if the game repeat infinite times, then there is room for punishment. Okay, so for example, if we achieve if we like set this agreement that both of us should produce low quality cars because 4-4 are better than 2-2, right? We should stick to this agreement. So both of us are better off. But if, like for instance, if I cheat, I deviate from this agreement, I play high quality car, for instance. And in that case, what is your response? You will also produce high quality car. Then we will end up to this high from low. If I deviate, then we will end up to this high, right? If I deviate, then you will also deviate. Then basically, both of us will produce high quality cars. In that case, we will only get half of the payoff as before. This is not profitable for both of us. Then I will not cheat because it's too silly. It's just not profitable if I cheat this time because the game will play infinite times. if I cheat once, then maybe there is a punishment, and then I cannot get, I cannot get like double payoff 4 and 4, right? So in this case, two companies will just stick to this low agreement. Any questions? Okay. So let's start again to question 4, monopolistic competition. So monopolistic competition is, it is like market form between monopoly and the perfect competition. So basically, monopolistic competition. There are some firms, they produce, some products, some similar products, but those products are not identical. So basically, each firm has the power to set the price for its own product. But since there are some similar products, then the price elasticity of demand might be quite high, quite elastic. So basically, it's very limited monopoly power. Okay, let's look at this question. So we have demand, we have the total cost. So first, what will be the optimal price and the optimal quantity and the corresponding profit? And show this in a figure. And second, show the price elasticity at that optimal point. And then if the demand change, for instance, if there are more firms enter the market and demand shifts downwards from 54 minus Q to 52 minus Q, how does that affect the company? So calculate the price, quantity, and corresponding profit, and describe demand of the company's product in the long run, and show it in a graph. And the last, explain what companies can do to avoid ending up in the situation that described in question C. Okay, let's look at this one. Am I recording? Question 4, monopolistic competition. So first, let me write down the information, the demand, 54 minus Q, and we have total cost, Q squared plus 4Q plus 220. Okay, first, we can draw this figure. So we have Q and the price. So first, let's draw the demand. We know that this is our intercept, right? We have drawn this several times, and this -1 is our slope. So we have 54 minus Q. Okay, so here is P equal to 54 minus Q. And to determine the optimal price and the quantity, then we need to find the place, find the point where marginal cost equal to marginal revenue, right? So what is marginal revenue? That's the change of total revenue to change of Q. So by by selling one more unit to the market, how does your revenue change? That's the total revenue, or derivative of total revenue with respect to Q. Okay, so to solve this, we need what do we need? To solve the marginal revenue, we need the total revenue. How to compute the total revenue? That's the price times Q, right? So what is price? 54 minus Q times Q. 54Q minus Q squared. Now, if you take derivative of this total revenue with respect to Q, you will get 54 minus 2Q. Okay, marginal revenue is 54 minus 2Q. That's the first element. Second, we need to have marginal cost. Marginal cost equal to derivative of total cost with respect to Q, right? That's producing one more unit. How does that affect your total cost, right? So do we know total cost? Yes, it's given in the question. Let me just copy this one. We already have this total cost here. Let me move it to here. We have total cost, right? And if you take the derivative of this total cost with respect to Q, what do you get? You get 2Q plus 4. Okay. 2Q plus 4. For instance, here is 4. And we have 2Q plus 4, okay? So here intercept is 4. So we have marginal cost, we have marginal revenue, and the intersection point of this give us the optimal quantity and optimal price. We just need to equalize marginal revenue and the marginal cost. $54 minus 2Q equal to 2Q plus 4. 4Q equal to 50. Q equal to 12.5. And if we put this Q equal to 12.5 into the demand, then we get price, which is P equal to 54 minus Q equal to 54 minus 12.5, which equal to 41.5. So basically, here is 12.5, here is 41.5. Then we can compute the total profit. Let me use pi to denote for profit. Profit should equal to total revenue minus total cost. And total revenue, which equal to P times Q. Total cost, it's given in the question. Q squared plus 4Q plus 220. We have P and Q, right? So P is 41.5, Q is 12.5, right? So what we can do is to insert P and Q into this profit function. So 41.5 times 12.5 minus 12.5 squared plus 4 times 12.5 plus 220. And if you solve this one, you will get 92.5. Okay, question B, we want to solve the elasticity at this point. That's question B. Okay, so what is the elasticity? Price elasticity of demand, that's the percentage change in Q to percentage change in price, right? dQ dP times P divided by Q. So we can see that, what is dQ dP? That's -1. Can you see that? If you write this inverse demand as Q equal to 54 minus P, dQ dP is just the slope, is -1, times what is P? P is 45.12.5, and Q is 12.5. And the result is -3.32. So it's quite elastic, as I discussed earlier, right? So if the price changed by like small unit or small amount, then like people respond or react to this, people's demand change a lot. Okay, that's the elasticity. Next, if the demand, now if the demand decreases to 52 minus Q, because more competition in the market, we have new demand. Then what is the new price and new quantity? So again, we need to equalize marginal revenue and marginal cost, right? So to get marginal revenue, we need to to solve the total revenue first. Total revenue equal to P times Q, 52 minus Q times Q, which is 52Q minus Q squared, right? And marginal revenue is dTQ, dQ, which is 52 minus 2Q. What about marginal cost? It's unchanged because, right? Because the total cost does not change. Total cost is the same as before. So if you take derivative of total cost with respect to Q, you will get the same marginal cost as before, right? If you equalize marginal revenue and marginal cost, you will get 52 minus 2Q equal to 2Q plus 4, 4Q equal to 48, Q equal to 12. And if you put this Q into the demand function, P equal to 52 minus Q. Now we have the new demand, which is 52 minus Q, which is 52 minus 12 equal to 40. What is the profit? Total profit equal to total revenue minus total cost. P times Q minus Q squared plus 4Q plus 220. This is 40. The price is here. And the quantity is 12, right? I just use these two numbers, 40 times 12 minus 12 squared plus 4 times 12 plus 220. And if you saw this one, this is 68. Okay, so here is 68. And if you compare this with the previous case, where it's less competitive. So if it's less competitive, the quantity is 12.5, price is 41.5, and the profit is 92.5. And now we have more competitive case with lower price and quantity and lower profit. Because it's more competitive, demand shifts inwards. Okay, describe in a diagram, in the long run, what will happen? Basically, from question B to, from question A to question C, there. So, more firm enter the market because it's profitable. In the long run, let me show you. So for instance, let me first draw in this here, okay? So here is the case. So for instance, here is average cost, okay? Then what is the profit? So this is the profit, right? So here is the average cost, okay? This is the profit. But in the long run, this demand will shift inwards. Let me show you in this graph. So this is the price. Let me use P1, P prime. This is the previous price, okay? Optimal price. And in this case, we have some profit, as I showed you earlier, right? So we have average cost here. And the difference between price and average cost is your profit. But now, if there is a shift in demand, if the demand shifts inwards, let's see, shifts to here. Okay. In this case, if the demand shifts inwards, to here, okay? In this case, we have this P prime, which equal to average cost. In this case, there is no profit. So in the long run, this demand shifts inwards, okay? And then profit pi equal to price minus average cost times Q. So here is let me just use price minus. So this equal to 0, right? In the long run. So P equal to P prime prime equal to AC. In the long run, price equal to average cost, and there is no profit. And how can we avoid this situation? How can a firm in this monopolistic competition avoid this situation? Basically, we want the demand shifts to outwards, shift to the right again, right? Because we want the firm wants to create profit margin again. And then the demand will shift to the right. And this can be done through for example, product development or product differentiation, right? So that's question E. Okay. Last case, oligopoly. Oligopoly, when there are like, when there are very few firms, for example, this auto car industry, right? So there are very few firms in the market. And this one is an application of the game theory. Is similar to what we did in question 3, I think. Yes, question 3. So we have two companies, and if they form cartel, and no firm, if none of the companies breaks the cooperation, no cheating, then they make profit of 1 billion. If one of the companies break the cooperation, then the cheating company get 1.5 million, and the one did not cheat get 500,000. And if both companies choose to cheat, then they will only get 0.75 million. So first, we need to show this in outcome or payoff matrix, and then find if there is any dominant or Nash equilibrium strategy, and analyze what happens if the game play repeated 10 times. Explain the characteristics of an oligopoly. Right. Let's look at this one. First, let's create this payoff matrix. So I will just use T and R to denote for two companies for convenient. And then they have two strategies, no cheating and cheating. Payoff 1, 1, 1.5, 1.5, 1.5, 0.5, 0.75, 0.75. So this is very similar to our previous example. Okay. We can first find, we can first start from company T, okay? For company T, if R choose to, if R does not cheat, okay, then in this case, if R does not cheat, then what is the best response for company T? Company T should cheat, right? Because 1.5 is greater than 1. Company T will choose to cheat because 1.5 is greater than 1. If R choose to cheat, then company T will, what is the best response for company T? Also to cheat, right? Because 0.75 is greater than 0.5. So basically for company T, cheating is a dominant strategy, regardless of company R's strategy. It's always the best strategy for company T. Okay. For company R, if T does not cheat, what is the best response for company R? So company R will cheat, right? Because 1.5 is larger than 1. If company T chooses to cheat, then what is the best response for company R? Also, company R will also to cheat, right? Because 0.75 is greater than 0.5. So we can see that no matter how company T choose to like his strategy, it's always best strategy to cheat for company R. So basically, cheating is also a dominant strategy for company R, and it's a dominant strategy for company T. So cheating is a dominant strategy for both firms. Do we have a Nash equilibrium? Yes, which is cheating and cheating, right? Because that pair with two underlines. Okay, what if the game now played 10 times? So compared to previous previous game, the game played infinite times, but now the game only played 10 times. Okay, not infinite times. So will two firms choose to form this cartel and stick to the agreement? Because 1 and 1 is greater than 0.75 and 0.75. We know that no cheating and no cheating is not stable. I mean, because of this dilemma, it's not stable, but it has higher payoff, right? 1 and 1 is higher than 0.75 and 0.75, right? But if the game only played 10 times, will two companies stick to this agreement and no one choose to cheat. So if the game played 10 times, then, I mean, in the last round, for example, if the two players are, if we are the two players, okay? If we are the two players, and in the last round, I know, in the 10th round, I know there will be there will be no next round. There will be no 11th round. So basically, in the last round, I will, highly likely I will choose to cheat, right? Because that's the last round. So if I choose to cheat, I will get like I will get 500,000 more, right? And then there is no punishment because after the last round, the game stopped, right? And then in that case, you will lose 500,000, right? And since this table is like, this table, it is informed to both of us. So we know this table, we know this information that if one cheated, then you will get 500,000 more and the other will lose that 500,000, okay? So basically, you can guess my behavior. You will know that in the last round, I might cheat. And then what you will do? You will also cheat in the last round because at least you will get 75, right? So based on my, based on your prediction of my behavior, you will also cheat. So in that case, in the 10th round, then we have, there is an incentive to deviate, right? And basically, if the 10th round, if there is incentive to deviate in the 10th round, then it's already start from the 9th round, right? Because if I know that the last round, both of us will cheat, then from the second last, I will already start to cheat. Then I will get 500,000 more. And then this unstable pattern will go on and to the first round. So basically, then there is no cooperation at all. So we will stick to cheating and cheating. We will not stick to the agreement, and instead we will just end up to this cheating and cheating from the first round. There's no cooperation at all if the game only played 10 times. So last one is this characteristics of oligopoly. As I discussed, early, this oligopoly is very few firms in the market, and there are barriers to entry the market. For example, quantity limitation or product differentiation that cause barriers to entry. So there are players, they play this kind of strategy in the market. Very few players in the market. Those are the oligopoly. Yes. So yes, that's all the question.